let's continue, guys. So I'm going to start the Git from very much from the zero, right? So the concept that I'm going to explain you, then this is the only time we are going to invest some small time as a theoretical perspective, as a concept perspective. Otherwise, after knowing this concept, we will likely jump to the lab and start practicing and doing a lot of things over there, right? But the concept that I'm going to explain you, it is very much critical and very much important to know these particular concepts, I can say. Because if you again, I'm repeating, guys, the concept that I'm going to explain you right now, just please focus on this concept. You might feel you know the Git, you might feel I know these concepts maybe, but I can give the guarantee we feel it, we know. But mostly I've seen, especially in the corporate world, by training a lot of principal consultant or DevOps engineers, and they feel they know, but while when they listen to me this concept, they feel, oh, it's very different thing. I thought Git work in this way, but this is the actual way, right? And if you know these base core concepts of the Git, okay, I can give the guarantee none of the advanced concepts of Git looks advanced for you in the future. It will be everything in the future in any of the advanced topic Git will look very simpler to you, right? If you know the concept. So working on the stashing, working on the rebashing, right, working on merge strategy, you will see that will be the then piece of cake for you guys. Okay, so focus on this basis concept, I can say the core concepts of the Git. Okay, so let me start in this way, right, step by step, so you guys can comfortable what is happening. Okay, so idea is something like this, right? If you have certain data, okay, it will be any kind of data, and normal text data that is normally there in your documents, right? Or the data may be a code, because code is also like a data, right? Your C++, C or Java, Python code, that is also a data. And this data is again there in file, and those file, you guys know, is known as programming file. My point here is, right, whatever kind of data you have to keep the data in the file. There's no other way to manage the data. I'm talking more about if you want to keep the data in your storage or in your hard disk. So if you want to put your data in your hard disk or storage, okay, you have to first create the file, and inside the file only you can put the data. There is no other way to put the data. For example, it may be a programming file also. This is one thing. Second thing is all depend upon your data, or all depend upon your file, how critical your data is, how critical your file is. It may be a programming file. So if you are the developers, so for the most, maybe the important critical thing, maybe your file that is called programming file, because in the programming file you have your code with you. Okay, so let's focus on the developer. Let's say you are the developer, you have a programming file. Inside the programming file you have a code in, let's say, Python language or Java language, right? Now it is all depend upon the sensitivity of the code. What I mean by this, if you think this code is very much critical for you, all right, so it's a very common thing, we keep on doing a backups, right? So we keep on doing a backup. Why I say keep on doing, right, it's not one time, I'm saying keep on doing. What I mean by here is okay, because as a developer, what developer do, they open this program file or programming file, or open the file. Let's say they write first line of code or some function they created. That function is also known as algorithm they created. So let's say they write some for certain lines of code, all right, and they save the file, right? And this is the first day they have done this. Then again they come on second day, they also write second line or second paragraph or second function or the method of the class, whatever you guys know. They write some more code. Okay, so there might possibility right? I'm just focusing on one area. We slowly build multiple things on top of this. So I'm just building in such a way this concept that I'm just thinking in the mind that you guys are very new in this tool of versioning controlling. So we are going to, in some minute, we're going to understand what is SCM, what is VCS, what is distributed version controlling, what is centralized version controlling, and much more concept, snapshots and some more concept slowly, step by steps. Okay, so these are the let's say you are doing this perform, right? But you might feel as a one simple scenario that maybe where I'm keeping my file, my program file, where I'm keeping in my hard disk, there might be possibility, not guarantee, but there might be possibility my hard disk might crash and then I will lose my data. So it is good practice in that context. It's one of the contexts I'm talking about, to keep on having the backup of your file. Okay, but the backup would be not the one time we have to keep on doing. Okay, for example, today, this is the first day. Let's say I'm taking this day is 26th of Feb. So just today you create this code, and what you do, you create one backup. So this is the backup number one, B1 you created. Okay, then tomorrow you change something in this code, because way we write that code as a developer, we keep on updating the code, editing the code, depend upon optimizing the algorithm or optimizing the code, or some extra feature I want to add, more feature we added here. And let's say this is the 27th day, tomorrow, for example, and you added something, and again, whatever change you want to do, again, backup. Okay, now there's a two-way, either whatever backup you created yesterday, B1, right? That is, let's say 26th, right? This backup you overwrite. Either you can do in this way, or good practice and good planning would be, rather than you override, you can create one more backup that's called B2, new backup. Create a separate copy of the backup for on 27th. Okay, and why this is a good practice? Because there might possibility whatever change you do today. Okay, you change something in the code, and as a developer perspective, this is a very common thing. Whatever change you do today, possibility maybe your today's code might corrupted something. Okay, so maybe you have tested your code yesterday, 26th, everything worked fine. You run your code, you test your code, everything worked fine. But today you change something, and we don't know what change we did in this entire big code, because it's not that simple code. It may be thousands of pages of the code. We don't know what part we have changed in the code. So if you override the new code with the older backup, right, your older backup will be gone, and maybe this new thing what you change, it might not work. So there's no way we can go back. We can go back to see the last code. So I think you understand what I'm talking about. So it's good practice to create a separate backup file. Okay, so if this backup, whatever I'm doing here, it is not working. Okay, the thing is not working. So we have an older backup with us. We can just go and use this backup. Okay, and this concept normally known as a roll back. So we can roll back to this particular backup. Okay, to see what was working fine. And we also see the difference also. Yesterday, this backup has 10 lines, this backup have now 12 lines. So we can see the difference also between backup 1 and backup 2. To see the difference, what I did, what change I had done, because B1 backup working fine, B2 is not working fine. So I focus more on those differences, and then as a developer, I use my mind to rectify the issue. This is one of the things. Otherwise, there will be a lot of more things we can do with this backup. Okay, now the challenge here is, okay, so again, we are just slowly moving to the Git. This is not the Git, right? I'm just giving you some information, so you can, in some time, you can relate by these concepts what exactly Git is doing. Okay, so why we are doing multiple backups? Okay, so we have all the days copy. Anytime we can go to particular date and see at that point in time what code we have done, what changes we have done. So we can see the difference, if something not working, something working fine, or maybe I have to share some information to my other developer, other team, that this change I have done in my code that makes my code optimized. You can also take that difference part in the code, or maybe any kind of other scenario also. Okay. Let me take one more point here. Let's say next day, 28, I had done some more changes. There's third changes we have done here, right? And then same thing, I'll keep on doing the backup. And why we keep on doing the backup? One of the reason of doing the backup is if I lose my storage, my hard disk, then the entire code, or not and only the code, entire document data will be gone. This is one of the reason. But one more great reason of having the backup is, now because of backup, we keep on storing the per day information or per hour information, depending upon how frequently you keep on changing the code. Okay, per month, per week also, how frequently you're changing the code. Or it is normally the pattern is we write some code, we write some function, we write some method. It's called algorithm. If you feel now this part is done working fine, let's create a one copy, let's create one backup, let's do some more changes. Okay, now I'm done by one more idea, one more feature, what is called feature, let's create one more backup. So this is frequencies depend upon code to code and software to software development, right? So one more benefit of having the backup is, if some of the at point in time, if something might not work, so we can have the backup with us. We can go back, let's go roll back and start working from there also. This is one of the things. But in this scenario, what I'm talking about right now, in this scenario, we have one small challenge, right? The challenge is right now, let's say our frequency of doing a backup is 1 hour. Every hour I want to do a backup. And let's say my software complete development might take, let's say, 1 year or 1 month. So think, guys, how many backup you have to create. And you have to create, there's no other alternative way. You have to create the backup. Okay. For every hour basis, for example, this would be a frequency of your backup, right? But the only challenge is, let's say this entire code or the file in the program, let's say they're, just for example, let's say their size of the entire data is 1 GB. Okay. Now the code don't have, never be a 1 GB mostly. But let's say, just for example, your code or the entire program, you might have multiple files also, and let's say the entire size is 1 GB. It means, right, it means if you just change something in a smaller part of the code, right, a smaller part of the code, one minute, smaller part of the code, right, and because we are following this strategy of keep on having the backup. Why? One of the reasons I told you is we can do rollback, or as a backup copy we need. So after doing some changes every hour, we keep on doing the backup. It means this first backup almost going to consume 1 GB. Again, we are doing backup, same data, we keep on doing the backup, 1 more GB, or again around 1 more GB. Just by changing small lines on some KBs, we keep on doing the backup 1 GB, 1 GB. It means if your frequency is per hour 1 backup, so in a day, 24 hours, 24 GB you consume just for the backup, and you calculate by for the year and the month, depend how many backup you are going to do. So point here is, this way of backup we need it for sure, but this way of doing the backup won't be a big deal, is a big deal, I can say, right? It's not the better way to do. Okay, so my point here is, we want to save the storage. This is unwanted and unwanting wasting your final storage. Obviously it comes with cost. Okay, plus a lot of other issues also you will face. Okay, it will also slow down multiple things also. There's also one challenge you will face, right? So we have to use certain strategy that I can do a backup, I can have multiple backups, right? We can see the difference of the backup. The difference sometimes, guys, also known as delta part, means in the B1 backup you added some certain lines, in B2 backup some more lines you added or removed. So whatever things you change, that is called difference, and difference is also known as delta. Okay, so we need a backup to see the delta. We need a backup every hour over day to see the difference, right? But how to optimize the storage. That's what the point is. Okay, so we can do something like this. If I draw one more quick diagram here, we can do something like this. So what I'm talking about, how we optimize the storage, right? So idea would be something like this. Let's say this is your code, your programming file, or maybe any kind of data. It's not only the code, it would be any kind of document, right? uh, especially the text document, right? So what can we do? Let's say we write first lines of code. This is the first line, and let's say after this line I want to do a backup, right? So this is the first backup we have created. Okay, then what are doing, we are doing, let's say this is the 26th today, and tomorrow 27 will add one more line of the code. Okay, so what can we do? As a file perspective, this is one single file having two different lines or two different code type part of code, right? Is one single file. But if you do a backup, okay, this entire file entire file we have to do the backup. Okay, but point here is I want to save my storage. So we know already the file one or some lines is already been backup yesterday, that is on 26 in the B1. Okay, so there's no meaning to do the same backup again, even though we know this one single file, but there's no meaning to do the backup again that is already exist. Okay, so we have to use some kind of intelligence here. Intelligence means we want somebody who keep on tracking. Okay, this concept of tracking come in play. And there's one more concept that we can also use a concept called indexing, right? So what index and tracking means here is we want somebody or some kind of program, some kind of internal program who keep on tracking, or keep on checking that whatever data you have till here has been already backed up yesterday. We have this copy with us in B1. I want to do one more time backup. Why? I explained to you. Okay, I want one more time backup, but there's no meaning to do the same data backup in B2. It is already exists in B1. There's no meaning to do a backup again one more time. Okay, only thing that we have to do backup is whatever things we added extra, that's called difference part or the delta part. Only this thing we have to do backup. So this is the role of the tracker. They keep on checking what part you added extra. That part we have to do backup. So tracker is keep on tracking, and they keep on using some kind of internal tags. This is normally known as flag. They keep on adding a flag. Let's say A means we added something or appended something, right? Right. So now this time on 27, let's say after 1 hour or 1 day, when you do the backup, they again do a backup. They create new backup B2. Okay, but here in the B2, it look like we are doing entire backup, but it's not. Only the delta part or the difference part they will do the backup. Okay, but interesting thing is, if you go to the storage level, hard disk level, and try to find out the total space consumed by B2, so technically B2 is only consuming this much space of the second line. But if you try to read the file, let's say some command like cat command, right? Cat is command Linux to read the file. But if you try to read the file data from this backup, the interesting thing is internally they are storing only this part, the delta part or the difference part. But if you try to read this file with cat or any of the text editor or the IDE, what you will see, you can see the entire file, because for us we are doing a backup to back up the entire file. But interesting thing is storage, they are only consuming that much small space of kilobyte or maybe some bytes, only differential part they store. But when we try to read this backup, they will show me all the file. How is possible? Because this backup internally they linked with this backup. This backup. So it is something like this. This backup is known here is known as parent backup. You can think this is kind of child backup, something you can give this term here. So when we try to read the file or cat the file or read the file with any of the notepad, for example, text editor, okay, what B2 do? B2 first go to B1 internally, is not visible. They were doing this operation internally. You can think those who by chance know DSA, data structured algorithm. So you can think this kind of links they do with linked list as a data structure, just for knowledge. Even though if you doesn't know, don't worry, don't pressurize your mind to focus on this topic if you don't know. Okay. And anybody who know linked list, this is one node, the second node, they create a link with a linked list, and internally they create this entire data in a tree data structure. Those who know data structure, they might know tree. So technically this is a tree data structure they use. So, but that's not the important thing to know in the GitHub. I'm just giving for your extra knowledge. So what happened whenever you read any file, first they go to the parent. Okay, the tree word is not a top node because you might have multiple backup, B3 also. So B3 will connect to B2, B2 will connect to B1. So you go to parent and ask parent, in your storage, how much data you have. They said these are the much data we have. So let me first print this lines, use this line. Then after they provide their entire storage, then we move to B2. How many lines you have? They say I have added some new lines. So these are the extra lines we have. So this plus this together will show in your text editor. So finally, it looked like we have the entire data in one single B2 storage, but internally they are not storing the entire data. They're storing the delta part or the difference part. So finally, it will save your storage. So storage problem has been solved. Okay, it's not about storage only. If you keep on doing the backup, same thing, it will also impact the time also, because doing the backup also take the time, right? So it will save your time also. Okay, plus the need of backup is being solved because I need a backup of every point in time. So that's also solved. And guys, this concept is also known as point in time backup. Point in time, right? So we are doing point in time, every point in time, what are things has been changed, that's part only we're doing backup, but it look like we are doing the entire backup, but technically internally they only that point in time, what are things has been changed, they are doing the backup. In this context, if you're doing the backup of only of the delta part and keep on connecting behind the scene these two backups, right, to look like as a one single data. So that is a reason this kind of backup is not known as backup, right? In this world and in this kind of concept, backup is technically known as snapshots. So we keep on taking the snapshots, the copy only on the differential part. So now onward, I'm not going to use the term backup, right? Backup typically means copying everything again and again. That is typical meaning of the backup. But if you are doing a backup only the delta part, then this kind of backup is known as point in time backup, or you can use the term called snapshots here. Okay, so B1 is one snapshot, B2 is a one snapshot. One more interesting thing that might come in your mind is, okay, what if on the 26th, right, we are doing some change, we have added some lines, doing a backup V1 or the create a snapshot of B1. Okay, then next day, 27th, okay, rather than we added some line, we might remove some line from here. With this the coding we are doing, we have to remove some lines also, modify some lines also, right? So what if we modify, remove some line from here? So there's nothing we have appended. Okay, what we have done, whatever data we already had in 26th, we added, so we edited some data or remove some particular lines. Okay, so again, this is the beautiful thing about of the tracker is they know, okay, they know what exactly we are doing on the file. Okay, because they know from B1 how many lines they had, right? So trackers keep on checking, comparing. Okay, they say in the B1 first backup, initially let's say you put 5 lines. 5 lines. Okay, next to 27, okay, rather than you add a new line, one of the line from the 5 line you have removed. So what the beauty of this tracker is, right, or the indexer is, they keep on updating and say, I know line number 3rd has been deleted. I know line number 4th has been modified. Okay, the deleted means entire line deleted, or modify means they modify with some other text. So trackers keep on tracking everything. Okay, now in this case, 127 means next day after doing this changes, when you again do a backup, that's called snapshot B2 created. But in this B2, okay, there's no data appended. So there's no B2 backup doesn't contain any data. What B2 contain? They only contain this kind of flag. This flag is also known as a marker. So they added this marker in their storage and say line number 3 has been deleted, or maybe we added something as a modifier. So we say fourth number line has been modified with some kind of new data, or maybe we added some more thing here. There's A, so they write A here. Line number 7 added with this new lines and new lines of code. Okay, guys, this is called marker, or maybe it was sometimes known as flag. Okay, so backup is not only, or snapshot is not only contain the data, they also contain the marker. Okay, why we need this? Because because we are not doing a full backup here. So in the future, if anybody try to read a file from this backup 2, because this is the latest backup or snapshot we have. Okay, so what I want that point in time, what is the latest data I want to see. Okay, so how they do, again, they do the same operation. The B2 go to B1 and say, B1, how many data you have? This I have 5 lines. So so my program, before they give the this 5 lines to my my cat program or my any IDE, what the snapshots do, right? They will go to B2 and they check, does we added more line? Yes. So I will also give one more line. But does we modify this line? Yes. So before they give line number 4, they will give the modified data. So internally they do this operation. Before they give the older data, they give the newer data. Or before they give the line number 3rd, they will delete it, because we have given this marker 3. So they will delete this. So technically, when we presented our data to our text editor, we are giving the updated copy. So final file would be first line, second line, third line is gone because we added here. 4th line we give modified one, 5th line, 6th line, 7th line we give this added one. So for the user perspective or my developer perspective who are using this data, they will see the exact copy what is visible in this 7th of 27th of date. They will see the updated copy of it. Okay, so this is, guys, how the concept work. It is now, this is not only the concept work in Git. I'm going to Git. I'm just giving some information to you. So anybody who are from IT background, this is the very common thing you guys might have seen in backup and snapshots, and these are very common activity happening. Okay, but why I'm discussing this point to you, because Git is exactly working in this way. Only the term is difference in the Git. In the Git, we use different term or vocabulary, but idea is exactly the same. Okay, what I mean by this, in this Git, in the Git world, if you talk about Git as a tool, okay, what Git will do, we have a lot of features Git will do. I'm just keep on giving one by one features, and by today and you will come to know almost all the main feature of the Git. So I can summarize that point in time, and that point in time you will be comfortable with why Git is SCM tool or VCS tool. What is those tools or concept also we will understand. Now in this entire concept, if you talk about the Git perspective, wherever we as a developer work, or wherever we keep on doing something directly on a file on our data. Okay, so this part where we actually putting our main data, keep on changing the data. So this area or this part is known as working area. Okay, here this is the one thing where we as a developer work. So this area, we're keeping our data, we keep on changing the file. Okay, after this we are doing the backup. So this area is known as working area. Sometimes it's also known as WIP, work in progress area. Okay, this is called working area. Okay, sometimes also known as working directory. Okay, workspace also you can use. But after you doing backup, okay, this B1, B2, they store in some specialized area. Obviously, they consume extra space, but they store in some specialized area Okay, that area you can use a snapshot area. There's also a term you can use, but in the Git, this area is normally known as a commit area. Commit area. So commit is a one area where they are putting this. And why they use the word commit? Because whenever you do a backup, that I told you guys that backup is not a snapshot. So in the Git world, you are trying to tell that this part is done, this code is done. Now I feel my code has been completed. I want to create a snapshot of backup. So I want to commit this. For me, it has been done. This part is done. So 26 code is done, or 26 date code is done. So I would like to say thumbs up and means I'm committing right now. So typically in the Git world, right, this B1 is called snapshot, or maybe we can use backup, but typically doing this operation, okay, performing this operation is known as commit. So we are committing, means this code I want to do a backup, I want to commit this. And that is one of the reasons why this is known as commit area. This one thing. Okay, but if you guys try to visualize here B2 the way I explained to you, okay, when you do a second backup, for example, okay, this time we are only doing the delta part, and not only the delta part, we are also storing the markers. It means we need something or somebody who keep on tracking in our working area, what lines we have changed, added, updated, deleted, right? All the things. We need some tracker who check. So when I do one more time backup, that's called snapshot, that's called commit. When I do this operation called commit, creating this backup, we need somebody who guide us, okay, to what data to store, what marker to store. Okay, then who is doing this? This tracker is doing. So what is tracker is one kind of program, but technically, if you think about as a programming perspective, it means there's some kind of data into their management, right? Not I can say data, they are maintaining some kind of information here. Information also known as metadata, but better term would be information here. They're maintaining some information. It means this file, we change something, delete something. So they are maintaining this information. So it means whenever I'm doing commit will always check this information. Okay, and what this information maintain? They maintain that in this file that you're doing to backup, this line number 3 is deleted, line number 4 is updated with this data. So commit, technically I can say, first check this information, right? And based on the information they store in the B2. Okay, and this area where we are storing the information, who is storing your tracker, right, are maintaining the information, right? This area is also have a name, and this area is known as staging area. And guys, this is the main use and working of the staging area. Staging area will do some more thing, but this is the main use of the staging area. And that is a reason, okay, why commit only read the data from the staging area. And it is also compulsory why we have to put our data always in the staging area. What I mean by this, when I properly show you the entire diagram, you will understand what I'm talking about. But I'm trying to rate those who by chance know Git. Okay, I'm just giving this information to them. Otherwise, I will explain to you also. So in the Git, if you want to commit something, it is compulsory to put the data in the staging area. Why? Commit, the way the Git has been created, okay, commit always read the data from the staging area. Okay, commit has no way directly to get the data from the working area. Why? Because working area has no tracker. This is normal, if I open my notepad, I'm opening here, I'm working here, this first line, second line, third line. This is my working area, working progress area. If I deleted this line, nobody here to track. If I deleted this line or modify this line, maybe in the ID you can do undo, there's a different point. But as such, as a Git perspective or other kind of tool perspective, there's no one who is tracking what part I've changed. Okay, so we need a tracker. Okay, and where the tracker run or where tracker store the information, I can say, right, store the information, what part is we keep on changing. They're only maintaining the information, right? They're not maintaining the data, they're only maintaining the information. So that is there in the staging area. Okay, and when we're trying to do a backup of this file, there's what called commit. Okay, my commit will come to this information, this staging area, and say, now I want to do a backup too. Can you tell me with you from a tracker, from the information, what part is being updated? This is delta part. Can you tell me accordingly? I will store that well, the remaining delta part here. That is one of the reasons why we have a staging in between. So finally, if I try to conclude very quickly, we as a developer, all right, we're a developer, you have some data. Okay, and guys, you told you data is always in the file. So you have file 1, you might have more files, file 2, you have more file 3. Okay, one file maybe images or videos or text file, code file. Okay, and you guys know one more thing, if you multiple files, you store normally all the file in one folder. Okay, and the folder where you store the file, for the developer perspective, they are known as workspace. So there's a workspace, and in this workspace, we are directly working on this file of changing the code. So that is a reason this folder is also known as work in progress folder, or maybe it's also known as a working area. Multiple names they have, what I want to use, all the names are right. But if developer want to use Git for what? For this purpose. And if I give this purpose a name, okay, so we are doing backup 1, backup 2, backup 3. Why we're doing this? Because on 28th, if I want to go back, I want to see what data I had in B1. Because at that time, one of my features working fine. In B3, that function, my algorithm, that feature is not working fine. I don't know what I change here in my code. I want to see the difference. So because we have B3 backup, we have B1 backup, we can see the difference, and accordingly we change the code, or we will, whatever I want to do, you can do. Okay, so that is one of the reason I explained you already. So my point here is, so what we are doing here on 28, we have a different data, 27 we have different data, B1 we have a different data. So typically there's one more term you can use here. Okay, whatever data we have over here on 26, we create a backup or snapshot. How? Why doing a commit? Okay, so typically this part is also known as version. So we create a first version of our code, version 1. Then 27, we do some more changes, some more edit, whatever deleted, we create one more backup. So we can use one more term here called, we have created version 2 of our code, then version 3 of our code. And why we get the version? Same logic. I can do go back, or that's called roll back. Okay, this thing. So by this operation, what we are doing, okay, we are maintaining the version, and we are controlling the version. This is called version control system, VCS. So by this process, we are maintaining or controlling the version. So this system is the VCS, version controlling system. Okay, and if you're doing this version control system in the software part or coding part, okay, software code part. Okay, so this way we are managing this version, guys. This version can give you a lot of more benefit. I'm just giving one simple example here just to explain you as we go and progress. Okay, having this version will open a lot of possibilities in the terms of maintaining your source code. Okay, we can do lots of management in the source code, in the team collaboration perspective, project management perspective. As we go and progress in this course, I will explain you a lot of fantastic use cases on this, right? So if you want to do entire source code management, it's called SCM, right? Having the version control is very critical, VCS. So if you want to implement VCS, you really need some code. So we need some kind of program, okay, that is more related to developer, because developers are the one, or software engineers are the one who are more concerned about in the management of your source code. Okay, and one of the most critical part in the source code management is having the versions. If you have the versions, tons of things you can do, what we will see. Okay, so we have one tool, one software available. It's called Git. Git is one of the tool. Otherwise, there are more tool available in the market, but Git is now very famous, so we are focusing the Git, and we obviously we are in the Git training also, right? So with the help of Git, they give you a capability to maintaining the versions, so creating the snapshot or creating the different commits. Okay, and if you have versions with you and you can control the version also, what I mean by control, we'll see again what can you do in controlling the versions. So entire management of your source code would be very simple. So don't worry guys about this term called SCM and VCS. I just want to introduce very quickly, but as I progress in this training, I keep on talking about this term, and more in future when it's is going to come, you become more and more comfortable with this term called SCM and the VCS. There's one more term gonna come up called DVC or CVCS. We also talk about those terms with the pure practical hands-on. Okay, but right now, we have a Git. Git is a one software. Okay, Git is one software, and because this software, you have to install the software. And how to install, I think guys, in your learning management portal, where you guys, we have given the portal to you of in hash starting, I have shared one video where I explain you how to install the Git. Okay, otherwise by chance if you missed that video, just go to the video. Otherwise, what can you do, just go and search Git download. Okay, and there's one link come up. In this link, they give the options you have to download for which OS. In my case, I'm using Windows, so I'm downloading from the Windows, but if you have Mac and Linux, you can download for that OS. So click on download, double click, and install it. But in my video, I show you how to download, how to install. Nothing special, just click next, and it will install for you. In my case, Git is already installed. Okay, I'm not wasting my time for installation part. Okay. The second thing is, after you install the Git, because Git is software, Git will give you your own black screen that's called terminal. That black screen is also known as shell, and that is called bash shell. Okay, so in the Git, in this training, almost whatever we want to do in the Git for anything, we are going to use the bash shell of the Git. Okay, so in my case, because Git is already installed, if I search in my Windows, if I search for Git bash, okay, this app gonna come up, Git bash. After install the Git in your system, you will click here and it will give this black screen. Okay, and this screen is called Git bash or the terminal. And here, this is my Windows system only. Those who know Windows, in the Windows, whatever you have a CMD command terminal, it is something like this. Only they give you some later extra look and feel, and in this terminal they give some extra facility where you can run some command that is more look like Linux command. So even though this is Windows, but here you can run some of the basic command of the Linux. Okay, because we need some commands to test, so that gives some commands to you. That is only things that different. Otherwise, what is the normal terminal of Windows, same terminal you will see here. Same within the Mac also and Linux also. Okay, so otherwise, doesn't matter you have Windows operating system or Linux, the command of the Git that I'm going to explain you, they are exactly the same. There will be no difference in the whatever the operating system you want to use, right? This is one small thing. So this is one thing. Second thing is, in the Git, there's everything is same, but I might have to use some of the Linux command here. For example, how to create the file, remove the file, something like this. Some of the basic Linux command I'm going to use. So if you guys are comfortable with Linux, it makes more extra benefit to you. Otherwise, maybe not everybody is comfortable with the Linux basic command. That is one of the reasons I've shared one of my small video where I explain you all the small basic command of the Linux in your learning management portal that we have provided by the hash tag. So I think you got the mail when you do the registration or in the Git training. You guys got this video also. Okay, but otherwise, if you don't know Linux, that's okay. As when I keep on typing the command, I quickly explain you the use of that command. Okay, don't worry about this. So this is the Git tool I have installed in my laptop, right?